Hello and welcome back. Alright, so today we're going to talk about custom objects from the Orbital Mechanics tab. As you can see on the Orbital Mechanics tab, there's quite a lot of information. I'm not going to delve into it all that much. Mostly it is just background orbital mechanics information if anybody is interested in seeing what those things do and modifying appropriately depending what you want to do. I'll let you play with that as much as you'd like. What we're going to do today is we're going to talk about some of the custom objects over here on the left side. The main information that the workbook receives is based on this TLE source box group. Satellite TLE pull down refers to the Celestrak pull downs and can be referenced from the pull down on the satellites tab. The other options are from TLE, which if you wanted to manually input a TLE, you would copy it and paste it into cell A4 of the TLE and SatCat tab, and then that would be able to bring in any other TLE you want, something that maybe isn't available in Celestrak or an older TLE, something like that. The third option is manual TLE. And if I were to check that, it then brings in an area on the left side that is now visible that you can update or input any TLE information that you'd like. And by clicking single KML, it would generate it. If the stop box is changed to run, it will then run continuously. So we're going to go back to the satellite TLE pull down just so that I can go a little bit more into this tab. As you can see, these are the calculated values for the orbital elements and some of the other key parameters for the satellite object, mean anomaly at the delta time, etc. There's a whole bunch of information there. If I wanted to, say, choose a custom orbit or one of the preset orbits over here, I could either check the manual TLE box, or if you want to bring one here, simply click one of the objects. And in this case, I brought in a polar orbit. If you click something here on the left, it'll automatically revert to the manual TLE checkbox. And you can see you can change the delta time to bring the time forward by days, minutes, hours, however you'd like. So we're going to generate really quickly a polar orbit. Select polar, and we're going to click the single KML button, and this will generate just one time. So it has just generated it. It'll briefly go to the satellites tab and then go back to the orbital mechanics tab when complete. Okay, now you can see that it has completed. Let's go to the Google Earth window, right click and revert, and there you have it. You can now see the polar orbit as it is brought in, and this will automatically calculate the right ascension of the ascending node to whatever chosen ground site you have, and in this case it's Colorado Springs, Colorado. So let's go back. Similarly, we can choose sun synchronous orbits, and then it will automatically calculate sun synchronous orbits. You can do MEO, mid-Earth orbit of any type, and then it will bring it in similar to a GPS orbit. GEO, similar, or HEO, or a Molniya type orbit. One thing I do want to note is if from an orbit with a high semi-major axis, if I were to click sun sync again, it will prompt for sun sync. So in this case, we're going to type in a 400 kilometer height above the Earth, and now it will bring that correct value in. So we have the sun synchronous orbit. Let's go back to the satellites tab. We're going to pull down and select run. Going back to the orbital mechanics tab, let's hit single KML. And now it is generating that single KML, and you can see the delta time now is updating. So it takes a little bit of time, but you have hours, minutes, and fraction of a minute. So let's go back to here, right click, revert. Now you can see sun synchronous propagation, and that satellite is now going to move in that orbit until you stop it. Let's go back to the workbook, right click satellites, and pull down stop. And that will then stop and remain on this tab, and then you just simply have to go back to the orbital mechanics tab to continue. Okay, and now that that is complete, we go back to Orbital Mechanics tab, and that is stopped and it has reset delta time, because the reason that that updates the delta time is it manually changes the time now value on the date and time tab, and it will update that appropriately. So let's recheck that and go back to the Orbital Mechanics tab. We do have another two options. Those are special orbits, and you can see in the description here the description of the Cobra orbit and the Magic orbit, two special type orbits. Let's show you what the Magic looks like, and there you go. Now another option that you have, say you have the Magic orbit, and right now if you click single, it will just generate a single orbit. Let's see what that looks like really quickly. Okay, and now we're back. So we go to the Google Earth window, right click on Sun Synchronous, and revert. And there you have it. This is the Magic orbit. Let's go back to the workbook. Now we're going to choose another option, which is Create Walker. What this does is it creates a Walker delta pattern. So let's see what the number of satellites is. In this case, maybe 6. How many planes would we like? How about 3? Relative spacing, it just spaces the satellite out around the orbit. A 0 would make them at the exact same latitude for their respective orbit. Say, let's do 1 and hit generate. And it will then cycle through and create all of these orbits. Okay, and now that that's complete, let's go back to the desktop. There's a new constellation file we just created. We're going to hide the initial value, and there you go. There you can see the Walker constellation with the different colors and each object in the constellation. And you can do this for any of the other values. Anything over here, you can create a sun synchronous Walker constellation, etc. Whatever you'd like. We're going to go back to the defaults, and for now that completes today's lesson on custom objects and Walker constellations. Please tune back to the orbital dynamics calculations demonstration videos next time. Thank you.